So, have you ever wondered if one tiny, practically invisible online action, like, say, a tweet from a totally random account with 0 followers, could actually mathematically cause an entire society to collapse? Sounds kind of like a crazy sci fi movie, right? But it's actually the very real, hardcore scientific question at the center of a massive legal clash we're looking at today. Welcome to This Explainer. Today, we're jumping right into a really bizarre intersection where modern physics literally collides head-on with the traditional legal system. We're unpacking the fascinating case of Dr. Chen Jingyuan, and we're going to see how the hard science of complex networks challenges the very foundation of how our courts actually work. Okay, let's dive into this. Here's our roadmap. First, we'll hit the linear legal paradigm, then scale-free networks, followed by Avalanche dynamics, systems philosophy, and finally what all of this means for the law and complex societies. All right, section 1, the linear legal paradigm, reductionism in the courtroom. So the prosecution in this case relied on a strict principle called linear causality. Basically, it's the assumption that knocking over one tiny domino, just forwarding a post online, directly and predictably smashes into this huge macro-level result of serious public disorder. It's viewed as a very straight line from A to B. You see, the classical legal system kind of treats complex societies like simple mechanical clocks with these rigid gears. It assumes action A just mechanically forces result B. This worldview basically treats society as static and incredibly fragile. And the problem, well, it completely ignores the complex, messy webs where information actually flows, and it completely bypasses the natural feedback mechanisms of a society. Moving on to section 2, scale-free network topologies, hubs and peripherals. Here's the thing. The internet doesn't work like a rigid machine at all. It operates as what scientists call a scale-free network. Physicists like Albert Laszlo Barabasi showed us that node connections follow a power law distribution. And I know that sounds like a bunch of jargon, but it just means the network is entirely hogged by a few massive hubs, while the vast majority of nodes are practically isolated, with almost no connections at all. To put that into perspective, the structural inequality here is just staggering. A hub node, think of a massive global news outlet, has millions of connections. It can trigger massive information cascades basically at will. But a peripheral node? Well, Dr. Chen's account had under 100 followers, and most of them were inactive. In a scale-free network, a peripheral node is virtually an island. It has zero kinetic energy and, realistically, zero macro impact. Because of this extreme disparity, network robustness theory actually gives us a definitive scientific consensus. It tells us that removing a vast number of peripheral nodes has almost no impact on the overall network structure. They simply lack the structural muscle to push information into the main arteries of society. I mean, you literally can't break a system by removing a node that wasn't holding anything up in the first place. Okay, section 3, branching and avalanche dynamics, the math of propagation. Now, I want you to think about the decimal 0.1. In epidemiology and network science, researchers use a metric called the mean branching number, or R0, to track how many new shares a single post generates. The actions analyzed in this case had an R0 of roughly 0.1. This places the event in what physicists call a deep subcritical regime. Mathematically, it's the equivalent of dropping a single lit match into a giant swimming pool. An avalanche or a fire isn't just unlikely here, it is mathematically impossible. Let's map this out using a concept called the Galton-Watson process. First, the peripheral node posts. Second, because that branching number is barely above 0, the expected total shares max out at about 1.11. And finally, we hit immediate extinction. There's a 99.9% probability the information dies entirely within just 1 or 2 steps. So, out of 1,000 attempts, it extinguishes instantly 999 times. There's just no way around the math on that one. But you might be wondering, what about those rare viral events? Well, that requires something called self-organized criticality, or SOC. Imagine dripping sand onto a pile. Eventually, the pile becomes so steep it reaches a critical state. And it's only then that one single grain can trigger a massive avalanche. The takeaway here is absolutely profound. The danger is the critical state of the system itself, not the single grain of sand. Which brings us to section 4, systems philosophy and reductionism. Two worldviews collide. We are really looking at a fundamental clash of realities here. On one side, linear law demands direct causality, it assumes a static society, and it focuses on punishing individual, isolated actions. But on the flip side, the 21st century scientific worldview of complex systems sees causality as this nonlinear, tangled web. It views society as dynamic and emergent, recognizing that macro events are never caused by one single person. They are the result of the overall state of the entire system. This actually completely shatters how most people understand the butterfly effect. You know, a butterfly flapping its wings doesn't just cause a tornado out of nowhere. It requires the atmosphere to already be critically unstable, literally at the edge of chaos. In reality, perturbations from peripheral nodes decay exponentially. Social networks are naturally subcritical and absorb these tiny shocks really easily. You simply cannot scientifically use the butterfly effect to pin a systemic disaster on a single peripheral node. And that leads us into Section 5, Law in Complex Societies, Evolving the Cognitive Framework. Systems philosophy gives us a pretty stark warning. When an institution acts like a broken thermostat, it destroys its own negative feedback loops. See, in a healthy society, diverse information actually allows the system to self-correct. When institutions respond to tiny peripheral noise with a massive sledgehammer, they cut off that vital feedback. They end up creating a dangerous cycle that actually makes the entire society way more fragile. The source material frames this perfectly, noting that a system that punishes the provider of information chooses closed ignorance over insight, violating the basic principles of complex adaptive systems. By trying to violently enforce a static, linear order onto a dynamic, nonlinear network, those rigid legal responses actually become the root cause of systemic collapse. So this leaves us with a critical question, not just for the courts, but for all of us. Must our modern institutions evolve their cognitive frameworks from 19th century reductionism to 21st century complexity to survive in an interconnected world? The math pretty much proves that governing a nonlinear world with linear tools is a guaranteed recipe for failure. So the next time you see an institution overreact to an isolated online event, ask yourself, are they fixing the problem or are they just breaking the thermostat? Thanks for exploring this explainer with me. Keep questioning the system and catch you next time.